All right, so let's consider this problem. This is actually an MCAT example. How is the frictional force for this inclined plane? How is it affected if the angle theta is increased? All right. First, we want to figure out what is the frictional force. I have this scenario. So I'm going to draw my. Actually, I already have all the vectors labeled. So step one is completed. I've also already labeled the coordinates here. So you can consider that step two is completed. So I'm going to go ahead and draw these vectors. With the vectors resolved. There's my normal force. There's my static frictional force, Fs. And let's say that this angle is equal to 30 degrees. So that'll make this angle equal to 60 degrees. And so I can resolve my force weight into its components. So there's Fw sine of 60. That's the y component of the weight. And here's Fw cosine 60. That is the x component. Now I want to know what happens to the static frictional force if the angle theta is increased. So if this angle is increased, that means that this angle actually decreases. If this goes up, if it goes above 30 degrees, then that angle decreases. And the cosine of an angle as it's decreased is going to also decrease. So I know that the static frictional force, all right, let me rewrite this in just a moment. Another way. From applying Newton's second law to the x component, sum of fx is going to be Fw cosine 60 minus Fs. That's going to equal max, but it's not accelerating, or well, yeah, it's not accelerating because static friction doesn't work. And so I can solve for Fs. I find that Fs is equal to Fw cosine of 60 in this case. However, if I increase theta, that means that this angle will decrease, and that means that the static frictional force will also decrease. You can consider the extreme of this example, and that is when I have a block that where the angle theta has increased to 90 degrees, in which case there is no normal force. So Fn has gone away, it's equal to 0, and as a result, there is no static frictional force. So that's an extreme example when the angle has increased to 90 degrees. So we have a related problem to this on the next page. I want to know what is the minimum coefficient of static friction, μs, so that the blocks in this figure doesn't move. Now I'm going to go, let's see, I'm just going to go back to this previous figure, and I've already labeled the resolved vectors. So I'm going to write out Newton's second law. I'm going to skip right to step 4, where I solve Newton's second law for these vectors. So just to remind you, step 1 was to label the forces, and that has already been done. Step 2 is to draw the vector diagram. It's already been done, previous page. And then step 3 is to resolve the vectors. It's already been done. And now for step 4, I'm going to apply Newton's second law. Sum of the forces equals ma. I'm going to go ahead and redraw this vector diagram just so you'll have it here to see. I have my normal force, my static frictional force, I have Fw sine of 60 and Fw cosine of 60. I know that the acceleration of this blocks in both the x direction and the y direction is equal to 0 because it's stationary. Now I can say the sum of the forces in the x direction equals mass times acceleration. That is Fw cosine 60 minus Fs equals 0. And I can also say the sum of the forces in the y direction equals may. That is Fn minus Fw sine 60 equals 0. I also know that the static frictional force, the maximum static frictional force, is equal to mu s times the normal force. And I'm looking for this mu s And so mu s is going to equal Fs over the normal force. So it's the ratio of those two forces. I need to know what those two forces are. So over here, I can solve this for Fs, and I find that it's equal to Fw cosine of 60. I know the mass, which is 10 kilograms, times the acceleration due to gravity. I'm just going to call this 10 meters per second squared, or you could say 9.8. And then the cosine of 60 is 0.5. So that gives me 50 newtons. Similarly over here, I can solve for Fn. It's equal to Fw sine of 60. That's going to be 100 newtons. That's the weight, 10 times 10, times 0.86, which is sine of 60. So that's equal to 86 newtons. Now if I want to find my mu, that's just going to be 50 over 86. Which is 0.6. Right, so that's the coefficient of friction. Let's see, you can draw your vector diagrams here. I did that on the previous page. All right, try this quick test. Good quick test. And I believe that is the end of this chapter. When you're doing this quick test, and I'll come back as well when I do the solution, I also want you to consider what would happen if what is the acceleration of this block? So if you're working through these now, I also want you to tell me what is the acceleration of this block. No friction. I just have a block sitting on an inclined plane at this angle, and I want to know what is its acceleration. I'll give you the solution for that in a little while when we get the solution for the quiz up. And that is the end of chapter 4. You should be working on the homework. Hopefully you've completed the homework and working through those old tests and working on the concept tests as well.